The following lecture can be regarded as the first stage in the introduction of what I refer to as the detection-reaction model. The model, which will be covered in the next lectures, suggests some of the elementary operation principles behind the energy perception as a suspected critical processing stage in the generation of sensoperception-based human behavior. The concepts of psychoenergetics and energy self-perception that were discussed in the last lecture may come in useful when hypothesizing some of the fundamental mechanistic aspects of the energy perception within the framework of the detection-reaction model. While the model is predominantly focused on human behaviors related to the amelioration and conservation of the individual's genetic achievements, other types of behaviors, which are not directly concentrated on these, will be elaborated in the 8th lecture under the topic of behavioral states. The detection-reaction model can be regarded as entailing some expectancy theory elements and will discuss certain considerations behind the individual's decisions whether and how to respond to different experienced situations. Having said that, we should remember that no model can provide pinpointed and accurate predictions to every specific situation being encountered in life, and especially when taking into account the wide range of influences acting on every human. Accordingly, rather than aiming the model towards exhibiting an ultimate precision, I'm mainly interested in using it to speculate that, as a part of the physical evolution of nature, energetic genetic considerations direct and shape the formation of perception and perception-based behavior. Another important remark is that the model is expected to deviate during infancy and frequently also at old ages when the energetic dependencies of the individual on others are or can be high, and his or her mental and/or physical capabilities to establish or follow the hardwired guidelines are relatively absent. Whereas the classical spacetime perception is in charge of recognizing and identifying the basic consciousness foci, at its initial stages of operation, the energy perception is focused on assessing the genetic significances of this BCF to the individual and grading the assessments in order to prioritize their subsequent cognitive processing. I named the basic consciousness foci, estimated as relatively more significant in a certain situation, as genetic consciousness foci, and in short, GCF. In accord with that, the GCF can be regarded as coarsely predicted potentials of CP-identified BCF to facilitate or prevent, as well as to ameliorate or sabotage the individual's goals. This can be done either actively, with the individual initiating the interactions with the foci, or passively, without his or her active intervention and energy investment in the matter. The predicted potentials are pseudo-quantitatively correlated with what I call genetic motivation indexes, reflecting the immediate energetic genetic attractiveness of the assessed foci for further cognitive treatment and prioritized response to their presence. The genetic motivation indexes are referred to using the Greek letter mu notation. Considering these, I assume that at this stage, 1. The assessments of the motivation indexes and their grading employ both the cognitive functions used by the classical perception, including top-down processing which relies on beliefs encrypted mind structures, BES, and phenomenological conscious experiences of memorized emotions that involved emotions encrypted mind structures, EMES. 2. All assessments depend on the content distribution states of the observing individual, which are being hypothetically reflected by his or her individuality dimensions. The latter also project on the incidental biases influencing the assessments. 3. A third important assumption is that the assessments of the GCF and motivation indexes at this stage are mostly quantitatively independent of the evaluations made by the perception of the energetic self, whereas classical perceptive connections between the basic consciousness foci and some elements of the individual ecosystem are required and indeed being established, the perception of the energetic self does not serve at this stage as a direct reference for assessments of genetic motivations, and partly due to that, the obtained indexes appear as coarse and overgeneralized. 4. The grading process of the foci works as an efficient perceptive filter, enabling the individual to omit many energetically genetically insignificant basic consciousness foci from further processing, and thus to effectively screen a tremendous amount of sensed spatial stimuli. I will soon return to this process and refer to it as genetic lensing. Let's talk about the contributions of both the classical perception and emotions to the assessments of the genetic motivation indexes and their grading. In the book, I examine a case of a GCF assessment that is dealing with an unusual and extreme, yet possible scenario of an individual identifying a substantial self-conservation danger upon waking up and watching a person with a drawn knife bending over him or her. Scrutinizing the situation, one may notice that the individual has the tools to rapidly predict the evolution of a complex dynamics holding a fair potential to turn into something like, in quotation marks, a considerable body conservation danger which may put my life at risk. This prediction, envisioning an undesirable self-energetic genetic change, and yet refraining from directly relying on the current pseudo-quantitative state of the perception of the energetic self, can be broken down to several interlinked estimations. The latter are believed to require CP assessments involving overarching beliefs and associative correlations between the basic foci identified in the experienced situation and certain perceived elements of the individual ecosystem. I refer to these correlations as perceptive conjugations and, again, believe that they require no special quantitative assessments at this stage. Now, my book delves a bit further into these connections and discusses, among other related ideas, the relevance of assessing spatial dynamics and spontaneity in addition to factors such as genetic selfishness influences on the grading process. For now, I will skip these topics and their significant contributions which are facilitated by the classical perception and continue to the presumed role of emotions as energetic indicators in this initial stage of EP assessments. The expression of emotions as phenomenological conscious experiences fits very well with the current systemic need for a prompt reaction which does not significantly rely on previous energetic self-estimations. The seamless mind assimilation of emotion vectors while experiencing directly and/or through communicated impressions of others energetic genetic focused impacts of perceived spacetime events turns the transmissions of emotion encrypted mind structures, the EMES, into effective first impression indicators for later encountered situations, enabling instant course assessments of the BCF detected. I believe that as the cognitive comparisons performed by the classical perception access the BES stored memories of experienced situations and the spatial elements that have been entailed in them, they also bring back co-assimilated memories of emotion vectors which allow a quick impression for a potentially recurring energetic genetic impact by the presently assessed foci. One may notice that this speculated mechanism ascribes a major systemic role to the CP adjacent emotive factor, and that it implies an affinity between the BES and EMES storage characteristics. Assuming that, we may return to the example of the potential assault with the knife and acknowledge the extreme emotion expected to arise in the individual during his or her CP interpretation of the situation, which is possibly also reflecting the projection of an intense fear of death in this case. The combined utilization of CP interpretations and emotive indications is assumed to provide a quick and efficient means for what can be referred to as genetic lensing, a methodic cognitive tool for screening massive amounts of sensory information. This filter-like effect helps narrowing down the number of subsequent energetic assessments in attempt to focus on spatial elements of ostensibly higher energetic genetic potential. Despite its advantages, genetic lensing can still be criticized for being unreliable and overly subjective. Clearly, many factors contribute to the questionable trustworthiness of the emotion indicators. Among them, one can mention the dubious reliability of assimilations of past experiences, also in regard to error-occurring nature of communicative transfers. Recalling, in quotation marks, situations that have never occurred forgetting relevant experiences that indeed happened, incremental structural shifts in the memories, assimilation of overlapping emotion vectors under variable individuality dimensions, and biases via emergence of emotions which are not directly related to external to the individual events. These add up to objective variations in expressions of emotions between individuals and personal contradicting experiences. The latter can be exemplified by a child who became used to playing with a friendly dog and has adopted a conservation-related trust in their interaction, which was accompanied by experiencing positive emotions. Nevertheless, under certain circumstances, this child might still become severely beaten by the dog. I assume that in case that such unfortunate event happens, the combined memory assimilated mix of beliefs and positive and negative emotions will bias the child's assessments and determine his or her behavior upon the next encounter with the same or a different dog. Based on the set of contributing factors presented, I suggest that emotive influences on the assessments of the foci extend beyond the simple weighted average of different vectors embedded in emotive memories of CP-interpreted events. Now, despite their relative subjectivity and unreliability, the combined CP and emotive contributions indeed allow us to screen countless environmental stimuli and to navigate our lives, sometimes heuristically, by assessing and then interacting with foci which seem to be more energetically genetically important at this stage. Parallel to the efforts to assess the foci and prioritize their genetic motivation indexes, I acknowledge that the continuous actions and reactions of the individual in spacetime keep producing more and more basic foci for him or her to evaluate. I also assume that the individual keeps monitoring and assessing the evolution of some of the previously evaluated foci, a process that can be referred to as dynamic updating. Such activity requires mind functions promoting attention and concentration with respect to detecting effective changes in the significance of the foci and their relative grading throughout the experienced situation. To deal with fast-changing dynamics, I assume that the temporal foci grading is being stored in a short-term mind stack designated for this purpose, and which is possibly connected to the sensory memory. Upon the systemic discarding of the foci with the lowest genetic motivation assessments from the stack, the more significant BCF remaining, now referred to as GCF, becomes subjected to additional internal comparisons and updating. In addition to that, I hypothesize an all-embracing discard of BCF below an energetic genetic threshold level of interest. This will later allow me to refer to other behavioral states and distinguish them also on the grounds of these threshold levels. Now, the genetic lensing filtering functions save the individual precious time over countless insignificant estimations. With that said, I remind you that the BCF and GCF, which have now been shifted back to the energetic genetic background, can still be reassessed and reprioritized. These foci may occasionally also contribute as catalysts or inhibitors in later high cognition stages where practical actions are considered. Before moving on, I would like to suggest the existence of a mind-body feedback between the dynamic GCF graded layer formed in the individual's consciousness and his or her immediate physical and spatial sensory-oriented states. Such a feedback might hold some implications over the human's spatial positioning, as well as on his or her sensory scanning and reception processes. Being mostly unaware of these attempted feedback operations, accepting their inherent existence might challenge our intuition regarding the free will-like, unbiased way in which we believe that we scan and monitor the surroundings. The next lecture is slightly longer than the others, and as such I will consider it as combining two parts of the discussion. It deals with the assessments of actions and interactions which are assumed to be based on a methodic interplay between the individual energy perception and various high cognition processes. So far, I have suggested that determination, grading, and prioritization of the basic consciousness foci depend on the operation of certain mind processes and their multiple biasing factors. This preliminary stage of energetic genetic estimations is screening a considerable amount of sensory information while selectively allocating mind attention for forthcoming assessments and processing of the more attractive GCF discovered. I also expect the process of genetic lensing to lead to an increased systemic vigilance while performing the more pinpointed predictions to be presented next. So, in addition to screening information, prioritizing the genetic foci assists the individual in choosing his or her battles throughout the ongoing energetic struggle in life. Deciding how to approach these battles requires further assessments regarding possible action and reaction pathways with respect to the prioritized foci. I believe that the mechanism behind the generation of these assessments and which determines the preferred responses to the GCF is hereditarily shared between all humans. It presumably involves an inherent back and forth type of an interplay between the classical and energy perceptions, where following their perceptive conjugation to the energetic self, the energetic genetic assessments trigger classical spatial inquiries concerning various aspects of the sensory projections involved. The assessments at this stage demonstrate the first use of the energetic self as a semi-quantitative reference point in evaluating spacetime. Considering these concepts, it is possible to view the energy perception as relying on combined cognitive processing of external and internal to the mind fluxes of data. Being particularly interested in sensor-responsive perception-based behavior, the detection-reaction model considers a mind mechanism which relies on high cognition processes and that can potentially be described using predicted reactions of the kind shown here. The reactant, indicated by our event, corresponds to a referred event towards which a human response is being considered. For our purposes, it will reflect the projection of the highly prioritized GCF in the individual's mind. On the other hand, the R-self reactant represents the individual through his or her energetic self, as perceived at the time of the assessment. In accord with my previous description, this assessment is also correlated with a specific mind content distribution. Given that, I treat the P-self and the P-event as perceptive products of possible predicted interactions between the individual human and the referred event. At this point, I further note that a more comprehensive and complex yet accurate way to view the process is through assuming that the individual does not only consider himself or herself in ourself, but he or she is extending the assessment to further recognizable elements in his or her individual ecosystem. Presuming the methodic mind operations involved, I view the semi-quantitative reactants and products as often being linked to each other through what I previously called perceptive conjugations. The latter allow assessing and processing only specific connections between the event and the human which are relevant to the situation experienced. With that in mind, I believe that at this pivotal pre-behavioral stage, the mind is intensively engaged in assessing the self-energetic genetic implications of different interaction paths referred to as response channels between the R-self and R-event elements. With respect to the different predicted implications on R-self, the equation shown may hence be split into a set of more specific potential reactions, specifying the channels under consideration. Holding distinctive characteristics, each channel is hypothetically expected to have its own activation barrier to occur and energetically genetically affect the individual and occasionally also impact the referred event in a different way. I would like to note several remarks that seem to be important at this stage. The first is that despite referring to subjective perception elements, the mechanistic reaction under consideration can also be ascribed in a way to genuine physical or organic interactions. The latter occur between the underlying structural distributions associated with the GCF and the current state of the energy self. The latter occur between the underlying structural distributions associated with the GCF and the current state of the energy self, which have found physical proximity in spacetime, namely at the assessing individual's mind. A second point to emphasize is that our event may also correspond to a communication event, entailing mediated transfer of information between humans regarding spacetime and its properties. The third remark concerns my intention to focus the discussion, at least for now, on channels which aim to direct the individual to improve or conserve his or her energetic genetic state. Various aspects of other responses holding different primary incentives will be elaborated later upon discussing the existence of behavioral states. Next, it is possible to hypothesize that no matter how strict the mechanistic guidelines of the energy perception and its related mind processes are, their outcome will forever remain affected by incidental and more durable psychoenergetic and other influences, and among them fears and urges. These may lead, for example, to exaggerated predictions of the reactant and product parameters. The large variety of factors biasing the grading and prioritization of the response channels turns the human behavior to appear less predictable and robotic-like rigid, as compared with what can be expected from the strict mechanism behind it. In order to highlight and concurrently to simplify the significant contribution of the biasing factors to the cognitive outcome, I unite their overarching influences under what I call a unified bias function, to be abbreviated as a function of the Greek letter cite, to which a full coupling of the assessments taken at this stage is believed to be required. Adhering to universal physicalism, I regard the overall bias function and its origins as relying entirely on circumstantial physical occurrences which obey physical principles, yet are not necessarily serving any specific systemic functionality in general spacetime. Let's delve deeper into the detection-reaction mechanism. First, I emphasize the mechanistic shift from relying on coarse emotive and CP-based pseudo-quantitative estimations that facilitate the determination and grading of the genetic foci to more specific semi-quantitative assessments of the response channels. I believe that at the current high-cognition systemic stage, the perception of the energetic self is being integrated as a comparative reference point for the assessments, and that it is operating in conjunction with the imagination-assisted perceptive conjugation processes. To briefly demonstrate this, I return to the example regarding the potential knife assault in the bedroom and suggest that in contrast to the previous limited and general initial predictions for a potentially harmful self-impact, at this stage the individual may consider his or her own present capabilities to defend or avoid possible confrontation. Next, I claim that assessing the response channels requires additional CP-based estimations and predictions of forces and potentials which are expected to take part in the different scenarios. These are often ascribed to overcoming activation energy barriers with respect to possible actions which might be taken by the individual, by external elements from the focused event, and/or by third-party participants in the overall experience situation. Such energetic barriers are marked here by the activation energy EA notation. Now, one may already notice that this speculated description insinuates an involvement of basic physical principles in perceptive mechanisms. I will come back to this idea later on when discussing the perceptive physical dimension. Given all these, I suggest that the process of prioritizing the response channels reflects natural inclinations to maximize energetic genetic profits throughout the interactions with the referred event, and concurrently to minimize both potential losses and the investment of energy, and particularly excessive energy. So, in order to determine his or her behavioral responses to a referred event, the individual is believed to assess and grade several channel-specific indexes predicting the worthwhileness for implementation in the respective response pathways. The motivation indexes will be marked here using the general notation mu channel for a certain event. Along with different other factors to be discussed shortly, the grading of the indexes is assumed to correlate with the self-energetic genetic implications predicted for the channel-specific interactions between our event and ourself, as well as with the spontaneity of these. The energetic genetic implications can be correlated with a semi-quantitative index delta self of channel, which represent the predicted gain, loss, or lack of change upon comparing the two self-energetic states preceding and following the possible interaction, namely delta self channel equals P self minus R self. The spontaneity refers in this context to the ability of certain events to directly affect the individual in absence of a meaningful self-energy investment on his or her part, leaving him or her relatively passive in the situation. Basic examples for spontaneous reactions include background-like experience processes, such as the natural absorption of the sun's heat, or contingent-like circumstantial processes like effortlessly receiving an energetically genetically improving gift from another individual. A strong hurricane heading towards a less fortunate individual exemplifies, for instance, a spontaneous conservation problem. Accordingly, we can distinguish between human reactions, which in this case are directed towards spontaneous processes, and human actions, involving an active self-initiation of interactions with either spontaneous or non-spontaneous events. To keep things simple, throughout this lecture I will use the term reactions without further distinguishing between these cases. I'm also motivated to do so because of the causal conjugation of the event to the preceding sensory process, which has brought the event to the consciousness of the individual, making its assessments and the decisions regarding how to act to it look like a response or reaction. At this point, I would also like to emphasize that different reaction channels might also be facilitated via co-investment of energy by both ourselves and certain external to the individual elements, which either relate directly to the foci under consideration or to third-party entities affecting the event. Given all this, I assume that at this stage of high cognition activity, the individual predicts to what extent can his or her own responsive reactions to the referred event ameliorate or worsen his or her ourself, and what is the extent of energy to which I ascribe the notation E0 in for a certain channel based on perceptive conjugations, which needs to be invested in the execution of the response under consideration. Here I enclose a list of potential response channels, which, depending on the circumstances, might be considered upon assessing a given referred event. These include collection of energetic resources, enriching reception of resources, giving away resources, diversion, escaping, awaiting vigilantly, acceptance of consequences, ignoring the event, and communicating the event. This is only a symbolic list that can and should be expanded, and indeed I encourage the viewers to do so. In the meanwhile, I will use a few selected response channels from this list to exemplify the assessments being performed at this stage. One important response channel refers to the collection of resources and elevation of the self-energetic genetic state of the individual. The amelioration in this case is achieved by appropriating certain external to the individual spatial contents, a behavior which is often bound to social laws and conventions concerning ownership and possession. In this regard, I should also note that we humans intuitively believe that increasing our energy reserves can improve our genetic conservation. Now, regardless of an occasional reliance of its execution on additional external investment of energy, I tend to view the collecting response as based on active perception-based behavior, which is emphasizing its overall non-spontaneous nature. As was recently implied, recognizing this spontaneity is meaningful by itself for the comparative assessments performed with the other response channels. Let's take a look at the scheme displayed. It presents several fundamental expectation tendencies in regard to non-spontaneous event which involves a collection response by the individual. I should further note that such objectivity-seeking presentations tend to ignore the full spectrum of influences biasing the predictions, and which I previously unified under the bias function psi. We may hypothesize, for example, an ideal, bias-free situation in which the individual recognizes an abandoned hoard that he or she can and is also allegedly entitled to appropriate. Experience-based, CP-interpreted first glimpse at the discovery allows the individual to realize that ignoring the hoard and refraining from collecting it will not enrich his or her own ourself. This causal interpretation is reflected by the predictive index of self-energetic change, whose zero value in this case, namely delta self collecting equals 0, suggests that the potential increase of self-energy is not expected to be spontaneous. Such expectation is further marked by the dashed line on the left panel of the figure. Now, ignoring the precious hoard might bring about personal consequences, which I ignore at the moment, and in many cases the individual would be interested in scrutinizing the option to invest self-energy in appropriating it, as demonstrated on the panel to the right. Now, a tangible intervention of the individual in the situation, such as in the case of collecting, is expected to require some self-effort. The latter involves an investment of energy in carrying out the response itself, and regardless of its outcome. Abiding by the general spacetime's energy conservation principle, we expect this self-investment to happen even if the effort and its accompanied energy decrease in the individual are marginal, for instance when it comes to the modest kinetic investment by a healthy human collecting a desired object. Past experiences of the individual in spacetime enable him or her to estimate, often very coarsely but occasionally more quantitatively, this self-effort, again referred to here as E0inv, before deciding to interact with our event. To demonstrate this idea, an arbitrary extent of predicted self-invested energy was symbolically added to the figure. Another important prediction concerns the change in ourself due to the response. In the case of collecting, for instance, the individual expects that following the appropriation of the external resources, his or her ourself will increase. Since I treat this change here as a reaction which yields P-self, P-self is expected to be greater than ourself. Such predictions, and among them the resulting index of self-change delta self-channel, are believed to heavily rely on the mind's toolbox of operative cognitive functions, combining classical top-down interpretations with the perception of the energetic self as a reference for the assessments. Given that, it is possible to assume the natural aspiration of the individual to maximize self-energetic genetic gain through spatial interactions. This aspiration, which is indicated in the figure, correlates with the idea that higher motivation indexes, mu channel event, are generally ascribed to responses predicted as potentially leading to elevated delta self values. I will soon also discuss the symmetrical case of high value yet negative self-change predictions. Next, I would like to highlight several points which appear to be relevant at this stage. The first regards the previous postulation concerning the overarching influences biasing the energetic assessments. Some of the influences are related to the individual's psychoenergetically developed profile and to the beliefs he or she has adopted throughout life. Among the latter are beliefs in different social norms which might occasionally affect, as in the case of taxation for instance, the potential personal gain, and can thus be considered as biases to the prioritization processes. Another interesting point concerns our biased tendencies to assess the expected energetic changes more optimistically or pessimistically as compared to the impacts they eventually leave. Furthermore, it might be that the assessments of the relevant energetic parameters often begin with individuality-biased, imagination-radicalized, utopic and dystopic interpretations. In this regard, I should also mention the potential biasing impact of expectations for reward or suffering during or after the responses, and their possible connection to experiences involving release of dopamine. An additional point to consider is that no solid factual correlation must exist between the practical outcome of the behavioral response and its prediction. In the case of the collection channel, this can be demonstrated by appropriating an object which, for some reasons, and unlike the initial prediction, turns out to have no positive contribution to the R self. Similarly, an uncertainty regarding the practical outcome is naturally expected to accompany at this stage all predictions in the possible response channels. The next concept, which is also pertinent to all assessed channels, deals with the systemic normalization of the expected response reaction variables with respect to the present state of the individual's relevant energetic self-resources, facilitated by the cognitive operations which enable the perceptive conjugation process. This normalization is first and foremost performed on the self-energetic change expectancy, delta self. In regard to a specific R event, I may hence write delta self relative equals delta self divided by R self equals P self minus R self divided by R self, or P self divided by R self minus 1. I assume that delta self relative, the estimated index of relative self change expectancy, is an important factor in the simplified detection reaction mechanism, relying on the normalization, and in absence of strong foreign biases. A rich individual who is aware, for example, of his or her bountiful possessions may ascribe a low delta self relative value to collecting a resource perceived as marginal compared to them. In contrast, the exact resource might be more likely assessed by a poor individual as more attractive and worth investing energy in collecting. In accord with these propensities, it is possible to correlate every channel-specific motivation index, among other parameters, with the relative self-change expectancy through a general formula like the one shown here. Examining the equation, one may observe that other predicted factors appear in its second term, factors that concern elementary practical considerations for a possible response. In accord with the assumed general tendency to minimize the self-investment of energy in the responses, which can also contribute to maximizing the relative profit, the formulation alludes a reciprocal correlation between the motivational index and the predicted energy to be invested, E0 inv, for a specific channel. Another practical type of factor refers to the individual's estimated self-potency to succeed, which is marked here as phi0 for the channel. This energetic self-perception conjugated, crude prediction entails assessments of own body and mind physical and mental capabilities, as well as of the current state of the self-readiness to successfully ameliorate or preserve ourself through responding in the channel under consideration. While the two measures, E0 inv and phi0, might be interrelated, they can also be respectively addressed as the self-effort required to initiate the response and the individual's potency, for example in terms of skills and feasibility, to successfully react in a way that will yield the anticipated energetic genetic change in delta self. In the case of the collection response, the equation implies that the attractiveness of this channel elevates with predictions of increased profit, diminished self-resources relative to it, low self-investment of energy in the response, and enhanced capabilities to perform the action and attain a genetic profit. Next, I would like to make a few comments in regard to the motivation equation. First, I assume that the equation is lacking an empirical validation, and as such, its algebraic formulation must be considered with extra carefulness. I also note that the equation does not attempt to precise mathematically the, in quotation marks, algorithm behind the estimation, but to provide us with some perspective of certain physically oriented assessments which hypothetically govern it. The second point is that regardless of its ostensibly straightforward and logic nature, I believe that the equation is coupled to the unified psi bias function. Despite the mathematical relation between the functions being for obvious reasons non-empirical, it is still important to this discussion. Now, the different biases acting on the individual may exhibit contradictions or trade-offs between their basic tendencies. As such, they often divert the evaluations of the motivation indexes and affect their follow-up prioritizations. One such case concerned the assessment of responses while experiencing poor or alternatively over-exaggerated confidence in self-performance. Such cases are respectively reflected by remarkably low and high biased values of the phi-0 expectancy index. Quite often, this factor appears to be more critical to the prioritizations of the motivation indexes preceding the chosen response than the predictions of high relative self-change delta self-relative or of a lower self-invested energy E0 inv. In addition to the circumstantial, momentary influences on the confidence levels, they can be also intuitively associated with experiences assimilated by the individual regarding the reliability of his or her energetic genetic estimations. This effect can be achieved through persistent comparisons and correlations between previous assessments made and subsequent observations of their outcomes. Now, my book discusses several other natural inclinations and biases, which I will not address in detail at this stage. These include, for example, assessments made upon collecting resources whose potential profits to the individual seem to overcome his or her estimated needs by a great extent, inclinations to prioritize responses which aim to yield smaller profits yet are being perceived as easier to achieve, the prioritization of channels associated with faster realization of self-gain, and so on. All these lead to some sort of trade-offs between the different parameters appearing in the motivation equation. Another idea is that the equation seems to be fairly generic, or at least easily adjustable to be applicable across all response channels and beyond collection. Moreover, relative adjustments to the formulation are probable when the response involves, among other possible cases, a combined investment of efforts by the individuals and others. I will briefly refer to cooperations between individuals later on in Lecture 10. One additional remark regarding the collection channel is that, unlike for the single individual, in its macro emergence from which it is applicable to groups of humans, it is reflected by a collection-oriented migration. Accordingly, it is possible to observe groups of humans who follow some sort of gradients of potential energy resources and catalysts while wishing that these will lead them to genetic amelioration. Another example of a response channel which is often being assessed and considered refers to what I call the diversion channel. This behavioral reaction applies mainly to events predicted as holding a spontaneous impact which can be deflected via the self-intervention of the individual. Such trends are illustrated in the scheme provided here. Changing the course of a spontaneous reaction requires a certain investment of resources and, if successful, the response can be viewed as leading to alternative, non-spontaneous products such as P-prime self and P-prime event. The interest of the individual in diverting such reactions typically stems from identifying conservation problems in our event, which are predicted to yield significant negative delta self values in the absence of an intervention. Possibilities to divert the dynamics of the event in ways which aspire to minimize the expected losses are then considered, as shown in the right panel 2 of the scheme. Naturally, during all assessment stages, the self-losses and their potential minimization can be hard to quantify, and as such, they often rely on coarse and subjective imagination-based estimations. These are still linked to certain reference points in the perception of the energetic self through the perceptive conjugation. I also emphasize that due to the expected potential loss of self-energy as a result of the spontaneous conservation threatening event, the relative energetic genetic change P-self divided by R-self minus 1 is assumed in this case to reflect a negative fraction whose absolute value limits range between unity upon estimating a maximal loss, P-self equals 0 and implying death, and 0 for an ideal harmless conservation response reflected by P-self equals R-self. As was previously mentioned, the drive to act in compliance with this channel is also assumed to abide by the genetic motivation equation. This can be carried out by using the slight algebraic modification shown. The possibility to divert and change the situation intersects at times with another response channel often being considered following classical perception and/or emotive-based indications of a conservation problem in the event. The alternative response corresponds to active attempts to reduce self-damages through escaping. As we know, in certain situations these attempts coerce the individual to sacrifice and leave behind self-resources, hence potentially decreasing the ourself. In accord with that, we may approach the common fight-or-flight dilemma via reduced comparative assessments of the delta self, phi0 and E0inv parameters in regard to the diversion and escape channels respectively. Doing that, we must still take into account that these predictions are possibly affected by various biases, including the individual's self-image, susceptibility to judgment by others, personal beliefs shaping his or her own principles and morality, emotional connections to self-resources and/or acknowledgement that they have been earned by hard work and/or prolonged efforts, among many others. While these influences occasionally drive the individual to favor fighting as an instance of diversion, substantial fears from the physical, social, or legal consequences due to the expected confrontations often lead him or her in other cases to escape. Once again, to shorten the lecture, I will not cover the entire list of potential response channels, but encourage the viewers to find new additional insights about them in my book. The next lecture will succinctly address the topics of cognitive biases and behavioral states, which are explained more comprehensively in the book. Let's start with the overarching influences believed to be biasing the cognitive assessments and the prioritization of the motivation indexes to react. So far, I have mostly portrayed the mechanism behind the energy perception as some sort of a serial set of methodical mind operations leading the individual to select his or her responses to interpretations of received sensory inputs. Such depictions may evoke a false impression that the human perception-based behavior automatically follows a pure, algorithmic type of unbiased conversion. While adhering to the concepts behind the suggested formulation, I wish to highlight the great importance of the biasing effect and refer to some of the factors assumed to be participating in the impact function psi. Increasing the complexity associated with the processes entailed, such factors provide to the sensor responses a more varied and less robotic character. Furthermore, viewing the different influences as converging in spacetime, namely converging in the mind of the individual during the assessment, allows me to describe this process as integrative and physically imposed on the individual via a restricted contingent deterministic physical dictate. Given that, one can distinguish between two types of biases: those which affect the treatment of the event foci prior to their assessment, including the clustering process of the foci as well as different exposure factors, and those which impact the subsequent selection of the response path. It is easy to see, for example, that interpretations and predictions by the classical perception that determine that clustering and assessments of the foci are biased by associations emerging alongside the intensive use of the imagination function at this stage. The associations blend into additional considerations regarding exposure factors, which themselves normally have little or no direct impact on the experienced event, and that are frequently biased by momentary consciousness attractors evoking in the individual's mind. Moreover, the interplay between needs, sensations, and awareness plays a tangible role in triggering and ignoring foci assessments, some holding a genuine potential to affect human behavior. Another quick example is the use of the imagination function in exaggerating the predictions regarding the experienced event, which often leads to over or underestimating delta self, E0inv, phi0, and the implementation times, among other possible factors relevant for the interaction. These add up to reasoning, communicated information which encodes beliefs, awareness and vigilance, age-related shifts prioritizing, for instance, conservation over improvement, and many other high cognition stage biases which are mentioned in the third chapter of my book. Nevertheless, one idea that has been somewhat overlooked in my writings is that some psychoenergetic elements that find their way to impact behavioral biases are being commonly transferred between frequently interacting humans. We may mistakenly associate these elements with heredity, as in the case, for example, of a traumatized father who transfers similar trauma-directed biases to his offspring, but in fact they should be considered as based on communicated beliefs and/or on behavioral projections of the biases. Earlier, I've assumed that the inherent incentives behind sensor responses are correlated with realization of specific genetic goals. As was claimed, the conversion of physical stimuli arriving to our body's sensory systems triggers a systemic mind process in search of potentials of energetic genetic value for the individual. This evaluation process presumably results in the generation of an energetic genetic perception layer whose experience lays over the spatial interpretations we provide to the sensed surroundings, and which leads to self-serving and, in the broader sense, self-individual ecosystem-serving perception-based behavior. Now, while assessments of gain and loss keep occupying the individual throughout his or her wakefulness hours, it seems that other behaviors, to which relatively lower energetic genetic focus is given, still exist. Inspecting our entire daily spectrum of activities indicates that we dedicate parts of our time to interactions holding other purposes. While clinging to the elementary detection-reaction principles proposed, I can still associate these behaviors and the human functionalities emerge from them to typical behavioral states recurrently being switched by every individual throughout his or her life. Abiding by the fundamental belief in structural functional correlations, I may even regard the possibility that the behavioral states employ different mechanisms within the mind's overall operational dynamics. Considering these ideas, I begin by referring to a prominent genetic focus state, which is believed to be centered on realizing, conserving, and improving the individual's own ecosystem, and which requires attention and concentration towards these matters. As expected, such activity entails the aforementioned reaction associated with the collection, reception, giving, diversion, and escape channels, as well as with communication, conversion of resources, and realization of targets, collection-oriented migration, and possible other behavioral responses. As a side note, I emphasize that we can also associate to this genetic focused behavior socially accepted conventions, such as seeking employment and working. Modern expression of working can be perceived as an evolutionary product of the energy struggle and of communicated beliefs. Generally speaking, we can see the work itself as investing energy and time in reordering parts of spacetime in ways that are believed to benefit us and also other benefiters who can reward us for these actions. Another fundamental behavioral state is related to escapism-focused activity. The human behavior in this case is associated with different interactions which are not directly intended to establish, conserve, or improve the individual's ecosystem and its continuation, yet are often deliberately chosen to engage in. Escapism-focused behaviors take up a significant time from the human's life and include a wide range of activities which are quite often, however not necessarily, pleasurable. Creating, playing, reading, and thinking are just a few examples for these. One can notice that some of the behaviors are covert and thus do not necessarily exhibit motoric expressions. Another point to consider is that certain leisure time activities, such as engaging in sports, socializing, and others, occasionally share both genetic and escapist characteristics. I also believe that some escapism-focused activities might circumstantially impact themselves the individual's perception of energetic self. Now, despite the possible connections between the two major genetic and escapist wakefulness behavioral states, I still view the engagement of the human in escapist activities as free of a clear intention to invest in their practice considerable attention, energy, resources, and time towards implementation, conservation, or improvement of own human goals. Another elementary behavioral state is ascribed to sleeping. Contrary to states of wakefulness, during sleep the individual's body shows an elevated passivity as his or her motoric control is relatively restricted. Being intensively researched, the sleep state is often associated with physiological reorganization processes which are believed to be necessary for sustaining the seamless operation of different life functions. Beyond the body rest and particularly the relaxation of the muscles, and apart from the homeostatic value of the sleep, I further correlate the mind activity taking place at this state with several systemic processes that affect cognition. One way to approach this activity is by paralleling it to a set of several capacitors interacting through methodically controlled charging and discharging reactions. One of these mind capacitor-like components is the short-term memory, abbreviated as STM, which appears to act as a functional stack temporarily storing encoded sensory, perceptive, and emotive assimilations. In every given moment, the memories present in the STM correspond to recently acquired assimilations from past charging cycles which still reside there for different reasons. The STM is presumably interacting, especially during the sleep state, with another capacitor-like mind array, the long-term memory referred to as LTM, to which some of the memories are being transferred for an extended storage duration. This is carried out through a systemic yet unique updating process. I believe that such capacitor-like charge-discharge operations provide necessary access to beliefs and emotions encrypted information which is then being utilized in the top-down processing of the sensor-responsive conversion processes. Accordingly, one may speculate that by following the fundamental inherent requirement for basic compatibility in the STM-LTM transitions and through an extensive reliance on the imagination function in achieving it, the consequent reorganization of the mind will shape the individual's spatial/energetic self and participate in their perceptive interpretations of spacetime. It should be emphasized that the top-down processing used in our perceptive interpretations further relies on short-term memories like the sensory memory, for instance, and as such does not necessarily require preliminary updating of the LTM in the sleep state for every encountered situation. Furthermore, we may hypothetically associate the phenomenological conscious experiences experienced during dreams with attempts of the imagination function to fluidly match parts of the memory arrays along the way to charge the LTM and reorganize the self. This is the finest hour of the mind events, which were mentioned in the event table in Lecture 2, allowing us to have a general impression of the individual's subjective world of associative connections. Next, one may ask why is the human being engaged at all in activities which do not necessarily help him or her to realize or ameliorate the inherent targets. One possible answer relates to the need to mitigate prolonged body and mind efforts invested in the genetic-focused behavior. This applies, for example, to the relaxation required for the muscles and to the revitalization of the mind's attention concentration functions, which tend to decline after sustained focused activity. Therefore, in absence of other forces interfering, sleeping and escapism-oriented activities aid the individual in performing better and staying sharp upon reverting from them to the genetic-focused state. Now, from a broad perspective, one may regard the escapism-focused behaviors as some sort of a gamble to the individual and potentially also for the species. As insinuated by their name, escapism-focused activities enable the individual human to temporarily escape from or repress fears and other negative emotions associated with genetic behaviors. By doing so, these activities can reduce potential inhibitions along the way to promote the self-goals. This powerful positive distraction effect is seemingly also incentivized by the experience of rewarding emotions while engaging in carefree activities. Nevertheless, such rewards can easily turn into addictions that lead the individual to overspend precious time on escapist behaviors and relatively neglecting his or her genetic targets. Furthermore, as leisure provides the individual with more free time to think abstractly, It can further raise by itself awareness to the fears or even trigger them. Such contrasting effects also apply to thoughts about the essence of life and to the potential implications of our order-seeking elusive interpretations which I believe we give to it. As is further highlighted in my book, I suspect that our only meaning stems from the serving of the greater physical evolution of the general spacetime, and from another perspective, that we might be genetically enslaved throughout this evolution to keep leaving behind sequential physical trace of individuality footprints by surviving, reproducing, and supporting as much as we can our next generations. Considering the various merits and risks associated with the escapism-focused activities, it is interesting to look beyond conventional anthropological perspectives and consider them upon analyzing different aspects of human behavior, including the evolution of this behavioral state itself. These ideas give rise to several additional thoughts. Based on the observations that during the escapism-focused and sleep states our sensory systems remain active, I assume that the ongoing interpretations of the environment in these states are associated with higher motivation thresholds, mu-zero threshold, than the typical values of the genetic focus state. Under these conditions, the relatively higher thresholds are believed to require a more significant genetic focal trigger to revert our attention to it and promptly refocus on genetic-based assessment and activity while returning to the energetic struggle. Abiding by these concepts, one may distinguish between the behavioral states by means of their different energetic genetic motivational thresholds. Given that, I assume that switching between the behavioral states depends on numerous factors, and among them, when not in the genetic focus state, naturally the sensing of the presence of a high energetic genetic potential mu event, urges, needs, emotions, and beliefs-related triggers. Sensing certain self-changes in the dynamic balance of the individual human energy due to different transitions, and biosignaling, which is also often related to the individual's age and habitual synchronization with some natural events. Next, I assume that recent events of switching between the behavioral states are memorized. Such memories can be valuable upon assessing the authenticity of situations experienced. Accordingly, no matter how realistic a film may appear from the sensory viewpoint of watching it, how deeply we immerse in its storyline, or how strong are the emotions it evokes in us, also when we project its plot on our narrative and identify with some elements in the plot. Using this memory function, we remain subconsciously alert that it is just a mediated and often acted projection of certain spacetime dynamics. Another hypothesis suggests that the sleeping state provides an opportunity to effectively reduce the potential buildup of excess mind charging by sensory energy during the wakefulness state. Such buildup is hypothetically associated with a high intensity DEST in sensory transitions, leading to an energy intake that is not entirely as well as effectively dissipated by conventional neurophysiological mechanisms. In aiding the energetic discharge, the sleep state supports a special condition in which emission of consciousness-coupled neural oscillations is more intense than sensory reception. As one may understand, I suspect that this emission, which might be peaking at the rapid eye movement stage, helps releasing the excess sensory energy that has been transferred to the human and has not found a way to be stored in his or her memories as well. Before getting further, I encourage the viewers to extend my reduced and symbolic list of behavioral states and correlate them to different genetic motivation threshold levels. Lecture 9 is about to hypothesize a pivotal concept in the discussion. I refer to it as the perceptive physical dimension of the human. The detection-reaction model implied that the human sensor responses are dictated by hereditary replicated cognitive mechanisms containing algorithms-like elements, such as the motivation indexes. These are coupled to both internal and external to the mind bias functions that can be algebraically unified around the physical nature of their triggers and impact. Whereas the algorithms impart a more mechanistic and robotic appearance to our perception-based behavior, the biases may enhance the arguably elusive impression that these responses are fully stochastic. Now, the high physical structural complexity of the human, his or her specific individuality dimension, and the dynamic environment triggering his or her sensor responses thwart any attempt to specify a reduced yet unified algorithm which can globally predict the precise responsive outcome to every life event experienced. A significant part of this challenge concerns the currently far-fetched task of decrypting the bias function psi and tailoring it to specific experiences. Nevertheless, I still believe that simplified models and hypotheses can help stimulating new perspectives, for example regarding the energetic considerations which might have been rooted in cognitive mechanisms through the evolution of nature. These big picture assumptions can assist us studying the systematicness behind our behavior and are far more interesting to me than optimizing the precision of any specific predictive formula. With that said, looking at the non-empirical or semi-empirical like motivation indexes suggested, it is possible to recognize that they contain elements from commonly adopted scientific principles which are also applicable to reactions in spacetime. These abide by different contingent conditions for spatial changes and among them physical compatibilities and the need to overcome specific activation energy barriers. One may develop this idea even further and hypothesize that the mechanistic cognitive guidelines behind sensor responses employ similar principles to those governing the inner mind reactions which physically trigger them, and that this similarity also applies to the reactions determining the external space-time changes which the sensor perceptions attempt to cognitively interpret. These ideas lead us to an important hypothesis, which I refer to as the perceptive physical dimension, in short PPD. The PPD claims that the operating mechanisms directing the cognitive processes behind the core sensor perceptions, with an emphasis on the energy perception, have been evolved and shaped alongside the influential presence of different energetic, entropic, and other physical principles, and as such these methodic guidelines both correlate with physical laws of nature and reflect them to a certain degree. Based on present scientific beliefs, we accept that ever since the Big Bang event and the physical laws of spacetime have not been changed, yet they have been persistently governing and contingently constrained the circumstantial conditions determining the evolution paths that emerged our human structure and functions. Negligible as they might be in the overall universe, some of these specific localized processes have naturally also contributed to the formation of the cognitive mind mechanisms under the focus here. Considering that, one can even analogize between the physical struggles in quotation marks that accompany the evolution of the human's mind and the energetic struggles being dealt by its energy perception mechanisms. Abiding by the PPD, it is possible to view the sensor or responsive mind mechanisms as inherent functional products whose operative guiding functions project on the relevant principles that facilitated their evolution in the human. In accord with that, I believe that the cognitive algorithms directing the different human assessments with an emphasis on the energy perception have evolved to reflect the operating principles and logics behind certain physical principles and laws of nature, including some of their circumstantial to the evolution process combinations. Before scrutinizing the hypothesis and its implications, I would like to emphasize that our genuine understanding of natural laws and their veracity will forever remain limited and doubtful. Among the reasons for that are the belief in traceability and other aforementioned perceptive limitations, as well as the basic uncertainty whether the current scientific reference points of truth will change sometime in the future. Accordingly, it almost goes without saying that one should refrain from validating scientific principles or attempting to indicate new ones by finding their potential analogies in perception mechanisms. An additional point to highlight is that while this possible bottom-up approach, assembling complex mechanistic guidelines from elementary physical principles, might be generically applied to all functional systems in nature, to the best of my knowledge, the suggestions to harness it for decrypting the operating cognitive guidelines behind the hypothesized energetic genetic perceptive layer in the consciousness, or other sensor responsive processes, have not been described yet. Looking even further to the future, in more advanced stages of exploration, this approach might complement or even replace the conventional top-down attempts to decipher cognitive processes by observing and analyzing the emerged functionality reflected from the triggered mind. Next, it is important to state that in the absence of a clear-cut proof and behind the inextricability limitations, it is reasonable to assume that my biased scientific beliefs have led me to suggest the existence of the PPD and to impose it on the perceptive mechanisms of the mind. Furthermore, as was insinuated, one can generally ascribe a physical dimension to any functional system evolved by nature and attempt to analyze it from this standpoint. By themselves, these possibilities do not contradict the potential veracity of the PPD or its compelling association with the mechanistic guidelines of the energy perception. Furthermore, I assume that behind the practical and theoretical restrictions, science might be able to combine various observations and interpretations in targeting and validating the PPD. Now, while assuming that the physical perceptive dimension applies to a range of physical laws, a subject to which I might dedicate my next writings to, I tend to focus at the moment on principles related to overcoming reaction barriers. In a broad sense, these include the activation energies and other physical compatibility requirements which generally conform to the contingent progression required for reactivity and conversion in spacetime, and in our case refer to those found in cognitive assessments related to the implementation, conservation, or amelioration of the human goals. Before moving on, I will skip several notable topics that have been mentioned in the book and which concern basic physical connections between the general evolution of spacetime and our present mind operation mechanisms, possible differences between human and other species minds, in spite of the invariance in the physical laws which have evolved them, the reliance of the energy perception on both inherent PPD mechanisms and environmentally impacted mind structure distributions such as beliefs or emotion encrypted structures, and its role in explaining ostensibly non-scientific and counter-physical beliefs, and similarities and differences between PPD-directed humans and algorithm-programmed robots. Next, one may intuitively indicate the common energetic grounds shared between the energy perception and the energy-related principles which ostensibly dictate its cognitive mechanisms. This elementary connection can be further generalized with respect to the expectation to find enhanced correlations between physical property-specific principles and cognitive guidelines dealing with functionalities that are strictly related to this property. Quite clearly, the set of energetic principles entailed in our case extend beyond direction of the cognitive mechanisms and are also applicable, for example, to the potentially related processes of sensory receptor activation, neurobiological transformations, and so on, all constituting a marginal part in the overall conditional evolution of the general spacetime. My next belief is that the emergence of the PPD is independent of our scientific knowledge at any given point in time. As such, and irrespective of my previous assumption that this dimension might be indicated and empirically validated in the future, I do not view the cognitive guidelines as eternally bound to any specific human interpretations of physical principles, and among them to my model's simplified and pre-optimized non-empirical equations. Given that, and assuming that the PPD indeed exists, I expect it to be ingrained in the mind mechanisms of every individual, independent of his or her beliefs in its veracity. Another point to regard is that the PPD can be viewed as uniting physics and beliefs through intersecting their, in quotation marks, partly dual nature that was mentioned in the first lecture. Additionally, by believing that the deterministic channel connecting these two can be hypothetically expressed by the individuality dimension, one may further contemplate and ascribe extended philosophical meanings to the individuality of the human. Trying to adopt a broad perspective, I view the persistent efforts to empirically study perceptive mechanisms via researching human traits and attempting to reduce some of the observations into operational principles and algorithms as, in quotation marks, top-down type of exploration methodology. Based on the detection-reaction model and the subsequent assumption for the existence of PPD in some of its quantized-like layers, I suggest that the cognitive mechanisms behind the human perceptions should be explored through an alternative, bottom-up approach using tailored algorithmization of physical laws of spacetime. Among different possible strategies which can be used for this exploration, one may propose, for example, an initial comprehensive search also based on the top-down knowledge which has been gained for instances of parallelism between fundamental physical principles and perceptive or behavioral functional reflections in humans. Lower complexity principles may then be bottom-up integrated in order to yield more complex physically adapted cognitive algorithms that strive to fit the statistics of observed human sensor responses to relatively fixed spatial triggers. Assumed to be correlated with the biophysical evolution of the mind mechanisms, some building block laws are expected to project, for example, on the energetic barriers to progression, while variations in and combinations of such principles might be modeled in increasing levels of complexity. Now, discovering and studying PPD-related analogies and algorithms is expected to reformulate and improve my simplified symbolic detection-reaction model. Among other merits, a successful exploration of the PPD could also affect current machine learning algorithms that attempt to mimic human cognition and help predicting responses to various experienced events. Another point worth mentioning is that the research for imprints of natural laws in mind mechanisms may encompass both the micro and the macro levels of physics and matter. This means that they might also depict classical mechanic, thermodynamic, and other principles which apply, for example, to the bulk properties of spatial stimuli of perceivable macro scales. In this regard, the PPD might be also playing a role in mechanistic transitions that hypothetically occur in the mind, very close to reaching the life-death boundaries. One interesting assumption is that close to dying and the collapse of the human individuality, prominent changes in mind mechanisms take place. These relatively short-term, yet fast-acting life-death boundary effects that can be possibly associated with near-death experiences or terminal lucidity in some dementia patients might be initiated through signaling of self-sensing functions speculated to exist in the mind. Using a bit of imagination and some abstract thinking, the assumed dramatic transformations could be attributed to mechanistic transitions from a PPD-based reliance on classical mechanics principles associated with bulk mind states to quantum laws, which are applicable to less dense array of more discrete states. Now, in addition to the efforts to comprehend the fundamentally inherent cognitive mechanisms, we should also remember the complementary need for deciphering the bias function psi. Despite expecting the psychoenergetic and other individuality-related factors to remain an inevitable hurdle throughout the exploration, finding similar PPD correlations and patterns among many individuals might mitigate some of the analytical issues associated with the subjective individual impact. Given that, I'm also aware that a possible progression in our scientific beliefs and/or technologies can affect the decryption processes. In spite of the challenges, I believe that through extending the exploration beyond conventional macro-behavioral and meso-neurobiological approaches and following the suggested structuralist reductionist concepts mentioned, we might expand and improve the interpretations of our minds as wonders of nature that allow us to observe, perceive, and respond to spacetime while navigating our lives in it.